Awesome. So, service worker internals. Just to check the crowd, so how many of you guys know about service worker basics? How many of you guys have actually implemented service workers? Okay, cool. So let's get started. So I am Puneet. My name is Puneet Priyadarshi. I am a software engineer with Microsoft Edge NTB team. So we take care of building the new, you might have seen the new Chromium-based Edge that came to market a month ago. So anything you click on plus tab and anything which opens up, our team owns that. And my core team helped building this page that you see, which is the new tab page team. So when you started this 6 months ago, our only core was that you need to be faster because it's a new tab page, so you need to be super fast. And our SLA was be faster than Chrome NTB. So that's where we started. Just a note that all the examples that I'll be taking in this particular talk will be all based on 1 Mbps download speed. Cool, so move ahead. So what is service workers? So to put it simply, it's a feature of browser which takes your app offline. So it acts as a proxy that sits between your web application and network and takes decision based on the script that you have written. It has access to something special called cache storage API. And cache storage API can help store your responses. Just like any workers, it has no access to DOM. As I said earlier, it intercepts all your calls, all your network calls, and takes decision based on that. It's script-based, so you write scripts. You say that, oh, I want to listen to fetch events. I want to listen to install events. I want to listen to the service worker lifecycle and take decisions based on that. So every fetch, if your service worker or your page is making any calls, navigation call, script call, CSS images, whatever, it can listen to everything. It's all fetch requests. And it can take decision based on that. And it's very powerful because it can do a bunch of stuff. It can just get things from the cache storage, or it can do, you can do things like cache purging and defining caching strategies. And this is the majority of the thing that we'll be doing with service worker is if I made a call to get my document, say a navigation request, then I want to do something, want to write a strategy called stale while revalidate. I'll fetch it from the cache, give it to you, go to background, and fetch and update my cache so that my cache is always up to date. And you can do things like cache first, and network only as well. Other things as well like cache only. It's a successor of app cache. So we used to have app cache for making your web application offline, which was very abstracted. But with service worker, it is everything, the power is in your hand. The way you write your script, that will define you the strategies that you have to take your page offline. Suppose you have a page over here, and you have network. You have servers where you can serve your pages from. Service worker kind of comes in between. It's part of the browser. And any call that you make, this is response. So it'll go and check in the cache storage API, do I have this? Is there a cache match that is happening? It will say, oh yeah. Then suddenly it increases your network resilience. It will just give you from the browser itself. So there was no call made to network at all. And after that, because it's still while revalidate, it will revalidate in the background. It will send a call and update the cache on background. And just to let you know that your page runs on a main thread, and service worker runs on a worker thread. So it's not blocking your rendering. It's not coming in your critical path. It's everything happening on a background thread. Cool. So talking about pillars of service worker. So it was not something that was built by the browsers right from scratch. We had things like web workers already. We had this cache storage API was kind of spec'd out at the same time frame with service workers. And we have this fetch API. They pull all these three things and build something called service workers, which takes benefit of all these things. it inherits from WebWorkers, so the functionality is a lot like WebWorkers, but it is kind of a network proxy. So how to get started? So first thing that you need to do is you need to register. Suppose you need to have something called an inline script. Pretty simple. You have an inline script. You are doing navigator or ServiceWorker.register and giving it a ServiceWorker.js. This JS file is not downloaded in your browser as of now. You're just, suppose your main thread, which is kind of parsing your HTML DOM, at that point of time, it sees that, oh, I have this service worker registration, and main thread can't do anything about it. It cannot spin up another thread on its own. So it goes to its parent, which is the browser process, and says that, oh, we have this service worker, and there's a ServiceWorker.js file associated with it. What should we do? So it says that, oh, it gives to network thread that go ahead and download this for me. So the network thread takes care of downloading it, giving it back to browser, and then browser goes ahead and said that, oh, here's a worker thread. Take your ServiceWorker.js to a parse, compile, and eval script. So your main thread is kind of not blocked by your page. It can go ahead and keep downloading other scripts and start rendering, applying CS and everything, and this will happen in the background parallelly. So, and your ServiceWorker.js, which will be downloaded, will define your caching strategies that for this particular network request, I want to do this. And for this particular, say, CSS-based network request, I just want to give cache only. I don't want to do a revalidate because CSS and JavaScripts are, if it's hash-based, they are immutable. So just give you a back understanding. Suppose because we have this, because we work from the new tab page, folks, we have this perspective of tabs. So suppose you have 3 tabs running and you have like 3 main threads associated with these tabs. And then on the other side of the world, you have another thread running called service worker. So you'll not have 3 different threads running. You'll have a single thread which will be serving all these 3 threads. So any request which is going from here to network have to go through worker threads. So this side you have window. This side you do not have window. This side you have the topmost object called ServiceWorker global scope. If you do things like console.log or a performance entries that you want to find, you generally do window dot. There you'll have to do ServiceWorker global scope dot. Even like console.log or console.error, you'll have to do using that. So this is just the basic of service worker. Let's get into like how we started in the Edge NTP team, how we thought the service worker will be useful for us. So this is what our page looks like, and this is a page without service worker. And when we started, this is how it was. It just takes so much time. It was taking so much time to load. And this is an example of, as I said, 1 Mbps download speed. And the entire time to visually ready was 3983 milliseconds. And we were competing with Chrome NTP, which was 700 milliseconds on 1 Mbps download speed. So it was pretty heavy for us. And we wanted to meet that target to go live, to come up with our MFP launch of Edge. So we started recognizing the bottlenecks, that what we can find out what the issue is. So generally, this is what happens on your page, right? You have page navigation, you have statics download, you have parse compile, eval exec of the script, and you have layout and rendering in the end. That's the entire path that it follows. So page navigation is the first document that goes and downloads it, like Amazon.com. So it downloads a document that your main thread deals with, and then it finds inside the document that there's a script tag or a CSS tag or a style tag that it downloads. So your entire page is kind of blocked until this task is done. It cannot start parsing compiling unless the statics are downloaded. So similarly, parse compile and eval and layout and rendering that happens on the page. As the numbers from HTTP archive, this is one of the major blockers that you have. To render a page, parse compile and eval takes the most amount of time. But we could not do, if you need features, you need JavaScript there. But here was an opportunity that what if we add service workers and provide these from the cache itself rather than going to network. So what we did was we added service workers over here onto these pieces. And what caching strategies we followed, like for the base page, which the document page, the navigation page which downloads is, we have this page, it sends a request to our server, but service worker comes into picture before that because it's up and running. And there's a cache match inside the cache storage API. And it gives it back from the cache response. And then it goes ahead in the background fetch and updates the cache. Same as I showed you earlier, it's a stale while revalidate strategy. So other was for caching strategies for statics. Statics is majorly your scripts, CSS, images, and whatnot, whatever you think is generally immutable, which does not. So if the URL changes, the content will change. So we have all our CSS and JS as hashed. After that, the say vendor.js results a vendor.hash.js. So if the hash changes, the content of the file will change. So we don't have to go to network to revalidate because we know that if my page contains this particular reference for these scripts, it will not change if it's there in the cache. So we don't go back to network to revalidate. If it's not in cache, it will automatically go. So it's called cache first strategy. It first look into the cache first, and if it's not there, it will go to network afterwards, but not every time. So we added those two, and our page navigation and status download on 1 Mbps speed, it used to be 300, 400 milliseconds. It came down to 40 to 50 milliseconds because it was just the cache read that you need to do to get those up and running. So there was a huge benefit that we got out of it. And the initial numbers, forget the initial number of the above the fold piece that we got was this. TTVR is time to visually ready, and quick links is the top sites that you see in there, and it was just 304 milliseconds to get that up and ready. So we became 350 milliseconds faster than Chrome NTP for the same numbers. And one thing that baffled me was this. We were 150 milliseconds faster than a local variant. So the Edge team, the Edge PerfLab team, has this local variant of the page that you don't have to go to network ever. Like you install this new Edge, and you were not connected to a network. If you open that page, new tab will not show you an error. They launch a page which is in the Edge resource. So it gets installed as part of your installer. So, and it was faster than that. So I was like, it's sitting there just in your desk, and it's just bringing that up and running, versus we are getting things from network or from cache and doing a cache read and taking it through path compile and whatnot. Why is it faster? So started looking into it, started figuring out, reaching out to people from Chromium project, understanding that what's going on. So Service Worker in Chromium and V8 does this amazing thing that it takes care of your parse, compile, and eval as well. So this was another blocker, bigger blocker in your that your script goes through the parse, compile, it runs a IFI, it waits for it to be executed, it evaluates it. So it takes a bunch of time to do that. And the more amount of script that you have on your page, the more time it will take. But if you're caching anything with your service worker, Chromium knows that you're going to reuse it. That's why you're caching it. Else there's no point of caching it. So they do something wonderful called bytecode caching. So they save everything in a disk or in memory initially as a bytecode. Once from JavaScript, it becomes a bytecode, then machine code, then it runs actually on your machine, right? So it's after they have transformed your JavaScript into bytecode, and they know that they're using service worker, then they save it as a bytecode. And that was not happening for the local page, because local page you cannot use service worker. You need to be HTTPS to use the service workers. So I started looking into that, what this bytecode caching does. What bytecode caching does is, when your V8 engine gets this, your JavaScript file, it does a compile script and then run script. So compile script does, it parses, compiles, and evals. And if there's any ifs, like a function which is initiated on its own, it does that. And it also waits for your entire script to be executed. Then it creates a code cache. And the next time, they call it a warm run. And when you do a hot run, it directly loads the code cache. And if anything that is just required for like just in compilation, they do that. Like if you're using a JavaScript file like settings or something which has not been used previously, they will just do it just in time compilation. And this is because of this why we became faster than a local variant of the page. So the takeaway from this bytecode caching is, don't add inline scripts to your page, to your HTML, to your document, because that will not be bytecode cached. It needs to be, the URL needs to be very unique for it to, because the URL of the JavaScript becomes your primary key for bytecode caching. So this code cache, they use the URL as the key that, oh, this is what they're looking for, and we already have a code cache, so just give the code cache. So avoid inline scripts as much as possible. So yeah, service worker pitfalls and optimizations. So we went through a lot of hiccups initially because we thought it's a silver bullet, just write it there and it's up and running and taking care of everything. But we figured out later on that it's not that easy. With, as they say, with great power comes great responsibility, right? So because you're writing the script, it's not abstracted from you. You are doing it. You are writing it. So you can write a wrong script. So the first example was our river. So we call it river. So we have news below the fold. So the 350 millisecond, if you remember, was just for this. We don't load anything below unless until user interacts with it. We use intersection observers. So if you intersect with that particular or interact with these, then we will load it. So I'll just show you that this is our page was. When you click on that, it will start loading. And this is how it behaved. It was slow for us. And we started looking into the bottlenecks. And we looked for the performance entries. And this was the biggest bottleneck where our news call to get the news was 720 milliseconds. Just to get the content. And then building it up, preparing and rendering and everything was on top of that. So, OK, plain and simple. Just add this to service worker. And just keep doing stale while revalidate, keep refreshing it in the background, and it's done. But the biggest issue that we had was that people who developed it will very intelligently made it a post request. That because it needs to be telemetry needs to be there, experimentation needs to be there. So you need to send a lot of data. So the query string was getting overloaded, so they added to the payload and made it so they were getting news doing a post request. And the first gotcha was cache me if you can, the post request. So if you remember this guy, cache storage API, which was one of the pillars for service worker, said that, oh, I'm good with get requests when it comes to post. No, we can't do that. Why are you storing a post request? Because post is generally for posting data, right? If you have a form, you post the data over there. But we're using to get. So what we did first optimization was we built our own post request storage inside for us. So if you remember this particular image of the pillars, we had the storage API. It was not supported anymore. So we built our own custom cache storage API, which handles both get and post. It can store both of them as much as you want to. So how it did was we have this awesome IndexedDB in place. So we built a promise-based wrapper on top of it, and which can store, which can cache your responses, like request response, just like a key value pair. And it reads the response when it comes back, the response body stream to the completion, into a blob, and reads the header as well, and uses the URL that the URL has been used as an ID to fetch it back. And when there's a cache hit, get the data from the IndexedDB, build a new response, and give it back to the page. So that's how we achieved it. And this is how our page was after. And this is on a 520 kbps speed. It was super quick. And when we saw that, OK, the 720 millisecond to get the news content was the biggest piece. Later on, we checked. It came down to 10 milliseconds, which was a huge win for us. And on my dev desktop, it is as low as 1 millisecond. So 720 millisecond to 1 millisecond. So we achieved there. Other pitfall that you can be, so with that, you can start storing all your post requests if you want to. Browser is very, very powerful. It gives you all the opportunities in hand. So other pitfall that we have with ServiceWorker is ServiceWorker preparation time. So when you start your browser, start your page, the ServiceWorker prepares itself. It runs the script and says that, oh, this is what I'm going to do. So it can, and it totally depends on the JavaScript you that write. So this is the official statement. The browser is starting up the ServiceWorker. So when we saw that initially that ServiceWorker preparation is taking 648 milliseconds, we just reached out to our browser team and said that, OK, it says that this preparation time is actually the browser is starting up the ServiceWorker. So it's something wrong with Chromium ServiceWorker. So and they started digging into it. They couldn't find anything to it. I suddenly found that tracing tool inside, even in Chrome, this is a Chromium thing. So if you do either Chrome tracing or edge tracing, you'll get this beautiful thing where it will trace the entire call that is being made. So you start this up, open up a new tab, and it will trace everything from V8. And you can choose options like what you want to trace. If you want to choose Blink versus V8, whatever you want, like worker thread, service workers, you can achieve using that. So when I looked into it, it came out with this, that V8 runtime regex was taking around 300 milliseconds. And so why it is taking 300 milliseconds? Why ServiceWorker is dealing with regex? And in fact, this is a script that we wrote had a regex, which waits for the entire body to be passed. See that, and that regex was taking 300 milliseconds. So the script that you're writing is also important that it should be vetted properly. Because, as I said, ServiceWorker is script-based, and if you're not writing the script properly, it can slow it down. So we fixed that thing, and it just went away. It became negligible. It came down to in microseconds. So yeah, the other pitfall is HTTP cache and mutable contents. So you have HTTP cache. Sometimes people think that if you have a mutable content, you can put a because there's a service worker, you can put a max age into it, but you can't. Service worker does not pass the browser cache. It goes through a browser cache. Even if you are doing a stale while revalidate strategy, it goes through a browser cache to make sure that if anything is available in browser cache, it will just get it from there rather than going to the server. So any mutable content that you have on your page, like your DOM, you should, not DOM, but your HTML, your document, you should not put a max age on it. You should not put, you should let service worker take care of it, handle on its own. So because it does not go through the browser cache, it'll just hit the server to refresh it. So here are some takeaways, like if HTTP cache, which is controlled by HTTP cache headers, sits between network and the service worker. So all fetch requests initiated from service worker still use HTTP cache. So if it finds anything there, it will use it. Mutable contents like, it says HTML, so typo, HTML documents should be marked with cache control, no cache. So it will not bypass it. So service worker will only fetch newer mutable contents from the server if it has changed. Immutable contents, like as I said, JavaScript with a hash in it, you can put caching HTTP cache max age in there. And if there's a cache miss or the cache is not found, or browser does some cleanup, or you do a cleanup on your own, then it can get it from the browser cache if it has to. So max age on a mutable content is generally a wrong choice to go ahead with. Other pitfall that I found out was the cache.match. So service worker does this cache match every time that you want, like you're getting your CSS or JS, say, it does a cache match. But if you do a cache match with ignore search parameters, right? Because it's a database, right, where it goes and finds every entry that it has. It's not indexed as such. So if you do ignore search, so it's not finding a unique one. It's finding all of them and removing a search and looking for it. something like this: cache.match event.request ignore search true. And there is an open issue right now on Chromium that if you have one entry and you do ignore search, it takes 10 milliseconds. And similarly, if you have 1,000 items, it takes 1,000 milliseconds to get one entry if you do ignore search. So never do ignore search. Other piece is never have a pass-through strategy. Like for our telemetry, what I did was I added a pass-through strategy. It was like ServiceWorkers was listening for fetch events, and when there's a telemetry request, we should always go to the server, and if it's offline, it fails, that's fine. So I added something called, I was thinking I'm very intelligent, so I added something like this. Oh, if we have listened for fetch, just do event respond with and fetch again. But this just adds another latency into it. So this type of pass-through fetch handler is insidious, and you will end up introducing a small latency hit every time. So if you don't handle this, browser will take care of handling it on its own. And suppose ServiceWorker is not running at that point of time and you made a telemetry request. You like scroll or something and say that you interacted with this. I need to send a telemetry request. The browser will have to boot up ServiceWorker again. It will have to go through that preparation again. So, which is not required. If you're not handling that fetch, it will just pass through. The browser will take care of it. So yeah, so browser is overhead in passing the response from ServiceWorker to the client. So not only just sending it while getting it back at will, it will come to ServiceWorker thread first, and then ServiceWorker will pass it back to the browser, which will be rendered again. Yeah, that's all pitfalls that I had and we faced. I don't know if you have enough time, Brendan, for questions. Oh, OK. So any questions? Yeah, go ahead. Sorry?
So when you're collecting the posts,
when
it's actually being sent to the server, how is that done? Are they each done individually? Are they done as a block?
So what it does is, so when this event, it will show you. So suppose this is the event, right? We got this event as part of the fetch. Suppose it was a post request. So what we do is we use something called event.waitUntil as part of the extendable event. And we wait until we go ahead and search. We send this request, event.request, into the cache match. And the cache storage API goes, and we listen to that URL. So it will have event.request.url. We'll go ahead and check in IndexedDB. Do we have this stored? Because that's our primary key. And if it's not there, we'll just call this. We'll just do fetch.eventRequest, and we'll attach a on-cache match callback into it. So once it comes back from the server, it comes back to ServiceWorker. So ServiceWorker will say that, oh, this is the call that I sent, and there's an associated on-cache match that we defined, and it will go over there. We'll add it to IndexedDB, and then send the response back to browser. OK. Any more questions?